So I prepared a bit shorter talk. Let's see how I will do. I thought I will give some of my time to Sabi, but he was perfect. Okay. So BBH events. We haven't talked about the BBH events so far, and we are discussing multi-messenger astronomy, and I'm talking about BBH events, which we don't necessarily expect much of other counterparts. They are just the gravitational waves there. So what can we do with BBHs in terms of multi-messenger astronomy, what they can inform us about? You guys already seen one of the versions of this. This is the latest public. This is the GWTC first catalog, which was published in December. So LIGO has 10 BBH events from 01 and 02, plus BNS event, which has been so much talked about. And of course, we learn a lot about them, not just the waveforms which we detect, but masses, spins, etc. So we get quite a bit of information, and of course, we get a sky localization. Of course, we are doing this. This is if you log on to the current run on GraceDB, which is collecting the LIGO detections. These are our public results. I got rid of the ones which we retracted. So far, there are 13 events, and you can find them, and we are giving localization in terms of direction and volume. And we also tell, of course, the event time to you all guys, and something about the constituents. So out of those 13, 10 were binary black hole mergers. And if you go online, this is an example for the latest one. You can find a sky localization. In this case, it's fairly good, around 500 square degrees, and the distance is around a gigaparsec with a large error on that, and you learn something about that this is probably BBH. There were other 3 events which may or may not have had some, but most likely had some neutron star content if they were not terrestrial. So you guys probably seen that, who follows up. If not, then it's just fun to look at it. So gracedb.ligo.org. And so these are the 13 events. And I looked into that, what's happening with these events. I went on to just looking at the GCN circulars and looked for the event number, and I did a control find. So obviously, the orange ones were followed up, or there were reports on them beyond LIGO. And order of 50 to 120, those were the neutron star ones. But if you look at the rest of the events, which are binary black holes, there are around 20 observations. These are not necessarily only observations, like there is an ice cube observation I am very aware of, but there are also some responses from Fermi, from Swift, but not really much from the regular optical guys, partly because of the large square degrees, partly because of the distances involved. And this is important, and I'm going to get to that in relation to the AGN case scenario, which I really want to talk about. So a possibility is that the LIGO BBH events are coming from AGNs, active galactic nuclei. So why are we interested in it? So let's just look at our own galactic center. Very recently, there were 10 X-ray binaries or so found in them. Okay, this is very interesting that very close to a supermassive black hole, we have definitely evidence that there are these binary black holes. So there is mass segregation, it's expected. So actually, there is quite a bit of density of stellar mass black holes within the inner parsec. That's good, because if there's large density, we may have more binaries as well. Okay, so if there is a dynamical encounter between black holes, and we can form these binary systems, which is one of the formation scenarios for the LIGO events we are seeing. That's not the only one, and I think Richard will say a bit more about others, a tiny bit more. Okay, so if we look at our own events, and we would like to, because that's the goal of this study, we'd like to determine the contribution of AGN disks to the BBH merger rate. This would help us also to study AGN disks and their parameters further. So the observation which can come out from LIGO and how we actually treat this in terms of this AGN BBH model will be very informative for other parts of astrophysics. So, all right. So what is this scenario? We never found the, oh, it is here. This is it, right? Okay. So we have these black holes around our central black hole, and they are orbiting. And what is happening, sooner or later, they will actually be aligned with the AGN disk itself, a good fraction of them. This takes somewhere a bit less than 10 megayears. And and there are lots of papers on this, but what our scenario says that they can actually, if it's a binary system, they can actually merge within the disk. And this is happening in an order of a megayear or less. So this is fairly fast process. Of course, the disk has quite a bit of matter, right? So there is the interaction with the disk. That's what makes the system to be aligned with the disk itself. Beyond the fact that we are looking for AGNs, we have a couple information from the LIGO events, which is mass distribution, spins, etc. So they can, if there is enough theoretical studies, they can also inform us whether there are certain cases where we would expect more relationship between the certain types of BBH events and the AGN scenario. Okay, so within the disk, as soon as a binary system, which could have been formed outside actually, or it could have been formed inside the disk, these black holes end up being trapped in these so-called migration tabs. And they may actually give a good chunk of the LIGO detections, as I said. So I am, of course, not a theorist. I am more of an observational person. So what can we do? This was our question. What can we do if we don't have an electromagnetic counterpart? Well, you take what you got. What you got is volume reconstruction from the gravitational wave events. And let's see whether we can use this information just based only the gravitational wave observation to have some idea on this theory of AGN origin. So is there a way that we can prove statistically that the AGNs are prime sources, not necessarily number one, but a good fraction of the BBHs observed by LIGO is coming from AGN. So how would we do that? Can we do that? So we certainly have a spatial correlation. We can use that for these somewhat fair source type. We have a volume reconstruction from LIGO. The other thing which we would and should need, but it's not well known, is the AGN number density. But this is a very wide range, and at the center that's fairly realistic number density. And the other thing where the observations, so how many LIGO events are needed to be able to make this proof statistically, is this AGN fraction. So what's the fraction of the LIGO events which is related to AGNs and coming from the AGNs? So let me point out this one point here. This is if all of the LIGO events are coming from an AGN, a LIGO BBH event, then we would need 100 LIGO events, BBHs, to prove this association statistically. So, but we need to correlate with AGN catalogs, and this is the caveat. We don't have them. We don't have them complete. They are not deep enough. We have events up to a couple of gigaparsecs. So that's what's really needed. As I mentioned earlier, this is another work beyond the correlation, which is just coming from the spatial correlation with AGN local, positions within the LIGO localization volume. We can also, and we may also use the inferred information from the BBH events, for example, the masses. This is a theoretical work which was done by Imre Bartos and his grad student and a couple of us from actually Columbia. And the main point here is that that the heavier black holes are more likely to be associated with AGNs than the less heavy ones. This is good for this case scenario because LIGO actually sees the heavier black holes further away. Okay, so that's another interesting point using the BBH informations which we do have. So another thing which we worked on recently, I did not mention one more observable from LIGO. We actually, I never tell you guys, but we do know the inclination to some extent for our events. So actually, it's expected that the binary black hole event's inclination is aligned with that of the AGN disk itself. So that helps us to constrain the localization volume by a factor of 3 better, which is going to give us, you know, much less, around also a factor of 3 less number of BBH observations to prove this scenario. So this is an active research, and there are many ways to go about it. And the big caveat is really we don't have enough information on AGNs themselves and the good catalog. So there are some catalogs which exist not very far from complete. This is why I find it's very important that our LIGO events are followed up. And not necessary to find electromagnetic counterpart, but just give us information on AGN catalogs. So what I would love to see that on GraceDB at one point we see, these are the AGNs in your localization volume. Whoever can do that and help us would be awesome. Of course, it would need to have some low contamination. Even the existing catalogs have fairly high contamination. It's not always something which is said to be an AGN is really an AGN, okay? So that's a problem. Some information on the AGN's inclination would be nice, and I know it's difficult, I understand that. I think it's easier to give it for us on our side, but it would be nice to have that information, and that also is up to the electromagnetic follow-up partners. So, but it doesn't need to be done fast. You know, our localization volume by the end of 03 or by the end of 04, you know, looking at or by the end of, you know, whatever is the next area. It depends on how long will it take to do this study. But, you know, you've got several months. It does not need to be done fast. So I have an argument here that we may be better to do something which people usually don't like, picking these binary cherries. But I think we should do that for this study. It has to be done and understood better whether this is the best way to go about it. My intuition at the moment says we have to pick the better BBH events, and of course the localization volumes where we have good enough catalogs. Okay, so this is my last slide. I was talking about a work which is done by many. It's led, we just put in a white paper for Astro 2020 that was led by Savik Ford from CUNY. And beyond Savik, a lot of the slides which I was showing, that was a work done in collaboration with Imre Bartos, Zoltán Hajman, Bence Kocsis, and Sabi. Did I leave anybody out? Hopefully not, but the names are definitely in here. So please read and look at our Astro 2020 white paper. We also had a workshop very recently in New York on this subject. And here is my final message. We need a complete galaxy catalog for the LIGO search volume. This is a couple of gigaparsecs, and as we get better, it's even more. It would be very nice to have a follow-up of our LIGO events, even though they are BBH. Right now we have those 20 observations, and they are not giving what we would need for this study. And there is quite a bit of work on theoretical understanding of AGN disks from a big chunk of this team, and I think that will be very helpful in this study, learning more about what kind of binary black hole events can be associated in terms of massive spins, etc., with the AGN scenario. So thank you very much.